Hello. So, in my last video, we talked about the product rule for taking derivatives. In this video, we're going to look at something else called the quotient rule. However, the quotient rule is really just the product rule, but a little bit trickier to work out, at least in general terms. Now, if you don't recall, the product rule, or if you haven't watched the video, the product rule says that the derivative with respect to x of f of x times g of x is equal to the derivative of f of x, or f prime of x times g of x plus f of x g prime of x. Alright, so the quotient rule is really made for, instead of dealing with f of x times g of x, we're dealing with taking the derivative of f of x over g of x. Now this is a little bit difficult at first, but we can easily simplify this to the derivative with respect to x, and this is a bit of a weird notation here, but it really just means finding the instantaneous rate of change of f of x times g of x to the negative first, right? That's what's putting it down there. And this can be worked out using the product rule. Alright, so we learned from this that first we need to take the derivative of the first function. Fair enough. So we can start evaluating this. So f prime of x, and then we multiply that times what we have in the second term, just normally, right? So that's g of x to the negative first. Right? Now, we add the normal first function, f of x, times the derivative of the second term. And here's where it gets interesting. Now we have to use the chain rule. So we have g of x to the negative first. We need to take the derivative of that. Now to the negative first is an outer function to g of x, which is our inner function. So as we learned a couple of videos ago about the chain rule, we have to take the derivative of this g of x to the negative first with respect to g of x. So we can use the power rule for that. We just pretend that g of x is equal to x. I'm going to use the fake x again. And then what's the derivative of x to the negative first? This marker is really bad. There we go. What's the derivative with respect to x? Of x to the negative first? Well, just power rule. Negative x to the negative seconds. Oops. Negative third, negative seconds. Alright, good. So that's the derivative of our outer function. So it's times, let's only keep the x's blue. I mean red. Times the derivative of this, which is what we're working out. Negative x to the negative seconds times the derivative of the inner function g of x with respect to x is g prime of x. Right? Alright, did I make any mistakes? Nope. No, I wrote that in red, that's not really necessary. Now, we simplify this more and plug our fake x back in. F of x, g of x to the negative first, plus fx. Now, this here, x, this is negative g of x, right? This is our inner function x here. We're taking the derivative with respect of x to the negative first. So x is just g of x. And then that's multiplied times g prime of x. We're almost there. And now we can turn these all into fractions to make things simpler to work out. we have f prime of x over g of x, bend down here, plus, alright, so what do we have here? Okay, f of x times g prime of x, I think, yes, yep, except we're subtracting, over g of x squared. Alright, and we're almost done. We just need to elaborate this a little bit further, simplify as much as we can. So let's just make these alike. So we multiply our numerator and denominator by g of x to get like denominators. So we have f prime of x times g of x, right, because we'll just cancel out, minus, this stays the same, and then now we have like denominators because we multiplied the numerator here by g of x and the denominator. So over g of x squared. And this is the formula you'll most come and see if you could. This is the formula you'll most common see about the quotient rule, but it's really important not to just use the formula and understand that you're really just doing the power rule. And a lot of the time, you won't even need to turn to the formula at all because it'll be easy enough to work out the inverses of the actual functions you're dealing with beforehand. Thank you.